NASA Ames has just completed the first new building on its campus in 25 years. It's a very exciting building. It's extremely energy efficient. It's extremely sustainable in its design and its functionality. The building, called Sustainability Base, was named after and in honor of the Apollo 11 astronauts that landed on the lunar surface at Tranquility Base over 40 years ago. Sustainability Base is designed to bring NASA technology and NASA ingenuity to create a living testbed for the evaluation of new energy-efficient technologies and approaches that can benefit the people of planet Earth as we move forward into the 21st century.
Cradle to Cradle is a design strategy that looks at materials as nutrition and looks at energy as something that comes from renewable sources and looks at water as something that's meant to be clean and drinkable. So this building is looking at its materials as either biological nutrition, things that should go back to soil, air, or water safely with a productive agenda, or looks at things as technical nutrients, things that can go back to technology, the steels, the plastics, and polymers, and so on. This is a really critical subtext for sustainability base. This building and this complex will have that fundamental characteristic.
Our solution for sustainability base for this building and landscape is really a combination of high technology and ancient wisdom. We were able to set the building on an east-west axis to take advantage and capture the breezes that are coming down the bay from the north on a daily basis and moving across the building site. So we could minimize the depth of the building to about 55 feet and create a building that really operates as much as possible on natural ventilation. One of the early inspirations that we had were these giant wind tunnels. They have this exoskeleton. They take the structure and they move it to the outside and they expose it so that they create a column-free space. There's no inhibition to the movement of air. This framework supports the seismic lateral loads in the building, but it also provides the armature for the shading elements that minimize the heat gain that we have in the building.
Sustainability Base was very cleverly designed. In lieu of a cooling tower, we've used a series of geothermal wells. That allows us to use a temperature gradient of natural water, pump it through the building, and to either adapt for heating or cooling needs as required by the building. It's a very state-of-the-art technology, and we're actually making it work. In addition to that, there are photovoltaics that sustain a great deal of the electrical power demand of the building. If indeed the electrical load, for whatever reason, becomes greater, we are supplemented by a device called a Bloom box from Bloom Energy, which converts natural gas as a fuel directly to energy. There are times when the building will actually either be energy neutral or will generate more electrical power than it actually requires, and we will contribute power to the power grid. What we hope to do is have a series of sensors throughout the building on all energy systems: lighting, heating, cooling, peripheral equipment such as printers, computers, and so forth. And at any given moment in time, anyone at a workstation will be able to call up how much energy is being consumed. And that will give people the information on which to make decisions that will allow them to be much more energy efficient stewards of their workspace and their professional environment.
Sustainability Base will have a unique water treatment system that takes hand wash water, shower water, water from all the sinks in the facility, and will purify that water to potable standards and then utilize it to flush the toilets. The technology that we're using is derived from a NASA spaceflight water recycling technology. For instance, all of the water on the International Space Station is recycled water. And the system that's going into sustainability base is just a larger version of that type of a spaceflight application. And then for irrigating and watering external, we are using tertiary treated water from local sewage treatment plant, so that the overall goal is to reduce the total water consumption of the building by upwards of 80 or 90%.
One of our major goals in this building was not just to end up with a great design. It was to end up with a very livable, very pleasant, very useful workspace for the researchers and employees of Ames Research Center. And we made our selection for all materials going into the building to be both healthy and as green as possible for the planet, not just for the individuals, but for the planet. So all of our products are Green Guard certified or Cradle to Cradle certified, and they have very few toxins in them. Those that do have low emissions. And the recycled material is in our furniture, it's in our carpets, it's throughout the products in the building. We also have the unique opportunity to reuse our products from Ames. We demolished one of our wind tunnels, and we took some of that product and we put it into our building. And as a result, we have oak flooring in our building that is warm and welcoming and a really nice reminder of Ames's history.
One of the things we are most excited about is that Sustainability Base will be a living testbed for innovative research. One example is the use of an anomaly detection software tool called Inductive Monitoring System, or IMS. In the International Space Station, IMS is used to monitor several key systems. In Sustainability Base, IMS will use data from building sensors located throughout the building to automatically learn how the building typically behaves, and then identify anomalies or changes in building performance that might otherwise go unnoticed. Other NASA-developed software solutions, such as Hybrid Diagnostic Engine, or HYDE, will be used to monitor the performance of the geothermal system. Prognostic models will also be deployed to anticipate faults and predict when maintenance is needed for the gray water recycling system. NASA will also collaborate with other government agencies, industry, and academia to try out innovative technologies for sustainability and try them out in Sustainability Base.
Sustainability Base is at the leading edge of what buildings of the future can and will be. It's an intelligent building. It's a highly efficient building. It's a building that informs itself and its occupants about their carbon footprint, about their energy consumption, and about how they can perform their jobs in a more efficient and effective manner. Sustainability Base is a living testbed for the future. It is an icon for what can be in the built environment. And it brings NASA ingenuity and NASA creativity back to the people of planet Earth.